Hey y'all, welcome to my house. Today you are going to be observing me conducting the lab dealing with thermal conductivity. Say that, thermal conductivity. The materials that I will use are 5 different jars wrapped in different materials. I have one that is not wrapped that will serve as my control. I have one wrapped in foil paper, one wrapped in a paper bag, one wrapped in batting, B-A-T-T-I-N-G. It's like a cotton. And then one wrapped in fabric. I'll wrap that up a little bit better in a second. We will also use a thermometer and some hot water. Take a moment and make some connections in your Google form about some things that we've discussed dealing with what you see here. If you identified matter changing from a liquid to a gas back into a liquid, then you are correct. As the water begins to boil, it goes from a liquid to a gas, which is known as evaporation. As the gas hits the lid, we can't quite see it here, but you will see condensation in the lid. So there's a little bit of condensation, okay? So this is a great example of scientists being able to make connections even though we're not talking about the states of matter. Today we're talking about thermal energy, and you should have written down in your notes that thermal deals with heat. One thing that we need to know about doing lab experiments is that in an experiment we have something called variables. Say that word, variables. A variable is something that you can change within an experiment. In order to make sure an experiment is valid, you only want to change one thing. Make sure you type that in your Google form. You only want to change one thing. The reason why you only change one thing is so that you can make sure your results are valid. If you have everything different in your experiment, you will not be able to tell what caused the change. We're going to do a lesson in a couple of weeks talking about force and motion, and we'll talk about designing an experiment and changing variables. But I want us to understand that when we do this lab, we only want to change one thing so we can see if the one thing that we're changing is what's causing the differences that we see. If you said materials, then you are correct. In this lab, we are testing thermal conductivity. We are looking to see which one of these materials is the best insulator of thermal energy or heat energy. We're not really looking for which one is the best conductor, but we're looking for which one is the best insulator. Because when we think about thermal energy, just like in our picture earlier, we want something that's going to keep the energy in and not burn our hand. If it lets the energy out, when we put our hand in the hot oven, okay, the heat from the oven is going to go through the material and it's going to burn our hand. So we want something that's going to keep the energy in and stop the energy from going through. All right, so now I'm going to be adding water to our jars. Remember that I said I'm only going to change one thing at a time. So I have a measuring cup so I can have the same amount of water in each jar. I'm going to add the water to the jar. Then I'm going to use my thermometer to find the temperature. Now I am not going to tell you what the temperature says. I'll just put it on the screen. One thing to know, when you put a thermometer in water, you need to let it sit to let it rise as hot as it'll go. So I may be stopping the video or chopping this video up so that I can move this along. Okay, so I'll start. This is the jar with nothing in it. I'm going to add the lid. Moving to the next jar. This is the jar with the paper bag. Moving on to the jar with the foil. Now this initial temperature should be the same, but there is a variable that I can't really control, and that's the water that's sitting over there. The lid is off, and you know, we've learned about states of matter, so the water, the gas is escaping, so it's kind of cooling it down. So that's why our temperatures may be a little bit different for each jar. Writing it down so I don't forget. This is the jar with the batting. I'm rounding these to the nearest whole number. These are decimals. Temperatures are slightly different. All right, and the last one is the one with fabric. Whoa, that is hot and it burned me. Whoa. What in the world happened? See, this is why y'all can't do this in the classroom. Y'all would be getting hot water all over the place. We are measuring in Celsius, not Fahrenheit. All right. All right, so now we are going to wait 15 minutes. And after the 15 minutes, I'm going to take the lids off of the jars one at a time, and I'm going to find the ending temperature.
All right, so it is 15 minutes later, and we are going to find the initial temperatures. So I'm going to open up the jar, and I'm going to measure this. Still going up, never mind. Make some predictions. Which one do you think is going to keep the temperature the same? heard some steam escaping. Made a noise. So now, okay, I'll stop.
So when you look at the table, the jar that has the highest difference is the jar with no wrapping. The jar that has the lowest difference is the jar with the batting. So what that actually means is the jar with no wrapping let the most energy out, and the jar with batting kept the most energy in. So what that actually means is the jar with no wrapping let the most energy out, and the jar with batting kept the most energy in.